Good morning, guys. We are going to continue our look at chemical equations today. Dig a little bit deeper into that, and I will answer any questions you might have about next day's test, which is tomorrow. And Mrs. Wood did send out an email again. I don't know if she sent it out to you or your parents, but the midterm exam and the Heritage Fair tomorrow is at Hollywood Road Education Center, which is on Hollywood Road. We're not meeting at the gym at Central like we had in the past. We decided to move it out to Hollywood. So just a reminder, go to Hollywood tomorrow morning. I'll be there probably around 8:30 or so if you guys show up with some questions and things like that. But if not, we'll begin the test at 9, and then it'll last for probably about an hour. Then we'll have a bit of a transition into the Heritage Fair. We'll be in the same room. And then you guys will be doing that for probably about 45 minutes or so to an hour. And that's it. So if we can go with a couple green check marks, just make sure everything's going okay out in internet land. And then we'll get started. While you guys are putting in green check marks, I will mention that we have been having lots and lots of headaches with the internet in our building and our school district in general. So I wouldn't be surprised if the video just gets knocked out, or the chat gets knocked off and the chat just disappears, and you'll have to sign back in again and stuff like that. So if it does happen, just be patient. We'll try to get things back up and running on our end as quickly as we can, but you should just know that it may happen. The second thing is that we do have some visitors coming in this afternoon to look at what we do in the building. You guys are not really affected by it, but if we pause, maybe, I think they're supposed to be here around 10:15. So anytime after 10:15, if I'm still teaching, you can just, hang out for a second. People might be coming through, or they might be typing questions into chat. Mrs. Wood is logged in right now with us. So she's gonna have a computer going in the room behind me here, the room you guys meet in, and she'll be answering questions with some counselors and some district higher ups and things like that. So that's kind of what today is going to look like. I do have a demonstration to show you. We're going to talk a little bit about chemical equations. So I figured, we've been talking about equations. Well, why not actually do some sort of experiment? So I've got two different things I want to show you guys today. Both I think are pretty cool. I'm sure you'll like them. You might have seen them before as well, but they're always cool to watch again. So there you go. That's kind of it. Does anybody have any questions about the midterm exam tomorrow at Hollywood Road at 9 o'clock? Anything in general about the test? Anything specific about material? Anything like that? I'd be happy to entertain any questions there were. And if you had questions about compounds, I left you guys with a bunch of compounds last day, and then I put up all of the solutions to those booklets. If there's something you got wrong or things like that, we'll be able to go through them right now. There's time. Okay, perfect, Abby. Abby, that makes sense to me. And Taylor, I'm gonna send your mom the exam tomorrow morning. I'll send it out to her probably around 8:30 or 9. So you'll have to print it or something like that. I'll send out an email with some instructions for you as well. So that is kind of that. Does anybody have any other questions about anything related to the exam, compounds, review, test? It isn't an online thing. I mean, you could have it in front of you online, but it's a paper exam. I didn't build it into Moodle like our other tests were already built in there. I made this one from scratch. So unfortunately, I didn't do an online version because everyone was coming in. So you might have to do it on the computer, and I'll send you the Word document. It should be pretty straightforward. I don't think you'll have any issues doing it on the computer, but it's not like a traditional online test. Okay, I'll see what I can do, Taylor. All right, nobody has any questions about any compound stuff. Does anybody have a couple naming equations questions? What do you mean by naming equations? Like naming the compounds, Abby? Is that what we're going with there? I wouldn't mind doing a few more balancing type questions as well. Okay. All right, so naming equations. All right, this is the extra practice sheets that I gave you guys. I loaded them up online there. This is on the naming ionic and polyatomic compounds sheet. Yeah, Alex, I can do that. And yes, Abby, balancing will not be on the test. So everything we did last day and today won't be on there. But I can go through some naming stuff right here. So naming ionic compounds and polyatomic compounds sheet. I'll go to the third page of that guy. And let's do a couple multivalent metal ones because they're maybe a bit trickier, and then we'll see where we end up. So please name the following ionic compounds. The metal is a multivalent, and you need to figure out which valence was used. So this is the trickiest ones, right? If your metal has more than one charge, you have to use a Roman numeral. If the metal only has one charge, you don't need the Roman numeral. So don't think you can sneak a Roman numeral in there. It would be wrong. If you're using like sodium, it always has a charge of +1, no exceptions. So we don't need a Roman numeral there. In this case, I'm dealing with chromium and oxygen, and I need to figure out which charge each of these things has. Now, oxygen always has the same charge. Oxygen is always -2. And it's telling me with the little subscript here that I have 3 oxygens, so -2, -2, -2. That gives me a total of -6. So that means that my chromium has to have a charge of +6. There's 2 of them. So if they were each +3, that gives me +6, and then it's balanced. So this is chromium 3 oxide. I don't have to put in prefixes or anything like that, and it's just chromium 3 oxide. Remember the prefixes, the mono, di, tri, tetra, those are all for covalent compounds. Maybe I'll skip 1 or 2 here, retrieve my periodic table. Let's look at the iron and iodine. Iron has 2 possible charges, +2 or +3. Iodine's always the same, it's always -1. So iodine is -1, iodine's -1, iodine's -1. I have a total of 3 iodines for a total negative charge of -3. I have 1 iron, and it has to balance out the charge, so it's going to be +3. So this is iron, 3 iodide. Sounds kind of strange, iodide, but that's how she goes. Maybe do one of these polyatomics down, like number 6 perhaps, and then we'll move on to a few balancing type questions. Number 6 is Hg, so that's mercury, and ClO3 is going to be something like chlorate or chlorite. Now I need to find my other sheet here, because I don't have that one memorized. So I flip to page 5 of my data booklet. I see that ClO3 on that page is, well, I can't find it. ClO3 is chlorate. It's up at the top. So this is mercury and chlorite. And chlorate off of the page in my periodic table, ClO3, has a charge of -1. And I have two of these things, so ClO3 -1. So I have two -1 charges for a total -2. I have one mercury to balance it out, so it has to be +2. So this is mercury 2 chloride. Maybe go to the next sheet and we'll do a last page. Maybe do a couple more of these guys and then we'll... Oh, did I change it to chloride? I'm sorry. Thank you for correcting me. Chlorate. I said it 3 times and then I changed the ending to ide. That's chlorate, which is not to be confused with chlorite or perchlorate. So you have ClO3, ClO, sorry, slide that over here. ClO3, ClO, what else do we have? ClO2 and ClO4. You got chlorate, chlorite, and perchlorate, all 3 different polyatomics. All right, last page. Let's do a covalent one, and then maybe do some balancing stuff. C and O are both nonmetals. So this is carbon and oxide. And because I have 2 of the second one, it becomes carbon dioxide. Let's do the next one below that, NaHCO3. So we have a polyatomic here because we have 1 capital, 2 capital, 3 capital, 4 capitals. So 3 or more gives us polyatomic. Usually, unless it starts with NH4, usually the metal is going to be by itself at the beginning, and then the polyatomic is going to be this HCO3. Now, this is one of these kind of, I don't want to say it's tricky, but on the common polyatomic ion sheet, page 5 of your data booklet, next to HCO3 is hydrogen carbonate, comma, bicarbonate. So you can pick either name. You don't have to include both. It's not going to be sodium hydrogen carbonate bicarbonate. That's not the name of this thing. You could call it sodium bicarbonate, or sodium hydrogen carbonate. So there's a few of them in the middle there that have more than one name. And if that does ever happen, you can just pick whichever one you like. I usually pick the short one because I'm lazy, and it is no more correct than the others. It's just kind of a common name and then a chemical name. All right. I see that Bria Alex got kicked out, and then Abby, you're having issues with the video, but we're back up. Back up. Just out of curiosity, you guys want to throw in some check marks again, and we'll make sure that everyone's with me still. It was my internet, not yours. Okay. Okay, well, I think it just might have been kind of isolated. I wouldn't be surprised if it happens a bunch of times. So hopefully we'll just kind of keep rolling, and if you miss something, just let me know and I can redo it or whatnot. Cool. Well, I'm glad it's working for some of you guys, and I'm sorry that it's not working for others. All right, so that's kind of naming. I'll leave it at that. Yeah, we'll just keep plugging away here. So we had one slide left in the notes to get through, and I wanted to talk a bit about that. I also wanted to do a few more balancing questions out of the learning guide. Alex, you had a question from the learning guide I said I'd get to. 6 on page 31. Let's jump to that. Is there a 6 on page 31? Or am I missing something here? So that's page 31, Alex, according to me. And question 6, I'm not sure which one you're referring to because nothing's numbered there. Maybe you could, oh, Alex got kicked out again. All right, well, that's not going to work. Maybe you typed in the wrong page number. I'm not sure. When he comes back, Alex is back. Page 31, there's no number 6. So if you wanted to throw that question in again, I'd be happy to go through it. Did anybody have an opportunity to go through a few more of these balancing questions? Like on page is this 33 or page 32? I know I did some of them. There's a 6 on page 31 for me. Does your page 31 look like this, Alex? Could do last one for question 7 on 33. Yes, Ava, I can do that. Last 2 in the practice, they're tricky ones. They get progressively harder. And then we cut out all the really, really tough ones. And I was going to scan them and put them in. But then most of your pages are numbered wrong. 4.3 practice. 4.3 balancing chemical equations. I'm not sure what's going on. Everyone seems to have a different set of numbers. So I have this, 4.3 practice, balancing chemical equations. And that is my page 30. So I'm not sure. Well, we sort this out. We'll do the last 2 balancing equations. I think it... I don't know, Alex. I'm sorry, man. If you figure it out, then good. Are you maybe talking about this one here? What are the 7 diatomic molecules? We haven't talked about those quite yet, but we will. All right, the last 2. Oh, yeah, I'm not sure. The last 2 here are both combustion type reactions, and they are the most difficult to balance because, first of all, you have oxygen on 2 spots on the right side, and then only 1 spot over here. And what normally happens is your oxygens on the right will be some odd number, and then you need to make it even on the left. And that's definitely what makes these tricky. So let's just see if we can get this balanced. So we have carbon, hydrogen, oxygen. That means we'll end with carbon, hydrogen, and oxygen. We started with 6, 12, and 8. So oxygen's in 2 spots here. And we ended with 1, 2, and 3. Maybe Alex, if you could just maybe write like some of the compounds it starts with, and then we could figure it out from there. All right. let's see what we can do here. So the first thing is carbon. I have 6 on the reactant side. I'll need 6 on the product side. So I put a 6 there. That gives me 6. But that changes my O's to 6 times 2, which is 12, plus another 1 is 13. And then I'm going to want to balance my hydrogens, which is going to be a matter of putting a 6 here. Changes this to 6. But now that changes my oxygen to 12 plus another 6 is 18. Well, this one's going to work out just nicely, I believe. I didn't want a 6 there, I wanted a 12. 12 and 18. Wow, you type that whole thing out. MgHCl, MgCl2H2, it's top line. Okay, thanks. I'll see what I can do with that once I'm done this, Alex. All right, so I need 18 oxygens on the left. I have 6 here, so I really need, out of this guy, I need 12, because 12 and 6 is going to give me 18. So if I put a 6 here, 6 times 2 is 12, plus another 6 gives me 18. So does that work? 6 hydrogen or 6 carbons. I'm going to double check this one because it's a bit messy. 6 carbons, 6 carbons. That's good. I have 12 hydrogens here. I have 6 times 2 is 12 hydrogens here, so I'm happy with that. I have 6 oxygens plus another 6 and 2 is 12 is 18 oxygens. And I have 6 and 2 is 12 plus another 6 is 18. So that one worked out okay. So that's a tricky one for sure. The next one's even more difficult. The last one here is super, super tricky. And once you do a ton of different balancing equations, Alex, I'll get to that in a second. Once you do a ton of balancing equations, you'll see that they just kind of follow some patterns. And there's a couple tricks that you can learn along the way. And we're going to run into a problem with this one, but we'll just go with it and see if we can work it out. CH and O. There we go. And then CH and O. Always 1, 2, 3. So this one isn't going to work out, and the reason that is because these pesky oxygens on the right side are odd numbered. So if I put an 8 here, that gives me 8. 8 times 2 is 16 plus 1 is 17 oxygens. And then I balance my hydrogens, and I need 18, so I put a 9 here, which gives me 2 times 9 is 18. My oxygens are 8 times 2 is 16 plus 9 is going to be 25. I can't put anything in front of a 2. I don't know why I keep getting all these boxes. I can't put anything in front of a 2 or multiply anything by 2 to give me 25. That's a problem. So what I need to do is just double everything. Because I have an odd number on 1, and I need it to be even because I have to have something even to put in front of to multiply by 2 over here on my reactant side, I'm going to have to just double everything. So the easiest way to think about this is just go back to the beginning where I started, and I'm going to throw a 2 in here. That's going to give me 16. 2 times 18 is going to be 36. And if I need 16 over here, I'm going to put in a 16, which gives me 32 plus 1 is 33. I need to put an 18 here. That gives me 36 hydrogens. And then 18 oxygens here plus another 33 is, was that going to be 52? $32 plus 18. No. Just 50. So I have 50 oxygens to deal with. So I need a 25 here, because 25 times 5 is 52. 25 times 2, why do I keep going 52? 25 times 2 is 50. I need to get 52 out of my head. So that's a tough one. And the only reason I can do that one so quickly is because I've done it so many times. And the trick with the combustion type reactions is sometimes you need to double everything because you end up with this odd even sort of thing. And that's something that'll come up with other types of questions. If you end up with an odd even scenario and you double everything, and I think we did this before when we were looking at some examples last day. If we have our blanks here, if you had like 2 in your first blank, and then if you had 2 in your first blank, and then like 4, and then you had an arrow, and then like, I don't know, 2 and 6. Well, you've got the right answer possibly, but these can all be divided by 2. So if you divide everything by 2, you end up with 1, 2, 1, 3. And that would be the simplest possible answer. So if you end up with double or triple the answer, or you end up at the end and all of your numbers can be divisible by some common number, then you need to divide it to get the simplest form of your answer. All right, Alex, let's see if we can find the question you're referring to. It's the page that starts with Mg plus HCl. That's page 30 in mine. I don't know why you have 31. But okay, so this is the 6 you're talking about. If the mass of all the reactants in a chemical reaction is 100 grams, will the mass of all the products be? This is a law of conservation of mass. If we start with 100 grams, what do we have to end with? There's no question 7. I'm not sure what's going on. Was that the question you're referring to, Alex? This number 6 here? Abby, you're right there, yeah. If you could type the question in, Alex, or help me some other way, then maybe your pages just got spaced out differently. I thought it was a PDF, so I'm not sure how that would happen, but maybe you had different scale or something. In any event, that's number 5 for you. I don't know what happened to the numbering. I don't know why it's all weird with you guys. Everyone's got different numbers. So I guess just writing in the page number and question isn't going to work. So if you have a specific question, it's entirely possible that you'll need to write the question in chat or just paraphrase it. Give me a random or an approximate page number. That would be super, super duper helpful. We'll just keep going. All right, in the PowerPoint, we had one slide that we needed to finish off. So we did these examples that weren't great, but we did them anyways. You guys should be a bit better at them now. Definitely balancing comes down to practice. It's not something you can just kind of look at and hopefully understand. It's something you do need to practice again and again and again. This is the most challenging part of this unit, and you're right, Alex, Unit 4 is so much more difficult than the first ones. And that's why I wanted to take a little bit more time to do this stuff instead of flying through it like the biology. But the last part, which I'm not sure why there isn't any questions in the learning guide, maybe because Unit 6 we get back into this stuff again, which we'll do next. But sometimes we'll be given a word equation and we'll be asked to convert it into a chemical formula and then balance it. So kind of 2 steps. And we run into some problems with word equations because it'll say something like oxygen. And you're going to need to know that oxygen is a diatomic element. And there's other things that are written down below here beside me that have common names. It'll just say methane. And you'll have to know what methane is, or it'll say something along those lines. So these are some really important things that you need to know. When we are writing word equations, it would be just the same as forming compounds like we've done all along. The exceptions come with what I like to refer to as the magic 7 or the diatomic 7. Now, kind of above me, you can see that there are 7 elements here that are highlighted in red. And they actually, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, they actually form a 7 on the periodic table. So when these things are by themselves, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, when they're by themselves, they don't exist as N or O or F. They're N2, they're O2, they're F2. Diatomic, di is 2 and atomic is atom. So diatomic is 2 atoms together. Now, we call them the magic 7, they form a little 7, and there's 7 elements. So if I count, I have nitrogen, oxygen, fluorine, chlorine, bromine, iodine, but there's only 6 here. Well, that's a problem. What is the 7th? 7 is the hydrogen. So when hydrogen's by itself, it is diatomic as well, so H2. So these are the diatomic 7 or the magic 7, and when they exist by themselves, they are H2, N2, O2, F2, Cl2, Br2, or I2. I call them the magic 7 because that sounds way better than the diatomic 7, and you can talk about learning magic in science class today. It's just an easier way to remember them, I think, just kind of refresh your memories, and you think, oh, the magic 7, Mr. Borden talked about those. So there are other elements which are polyatomic, but they don't come up as often. So like phosphorus is P4 and sulfur will exist as S8. I wouldn't bother memorizing those because they don't come up very often, but the other ones do. So H2, N2, O2, F2, Cl2, Br2, and I2. All of these guys are diatomic. So if I said, hey, mix some oxygen gas and some hydrogen gas, you would be really tempted to just write the chemical equation as O plus H, and then produces H2O. But it's not O and H, it's O2 and H2. Some other common ones, methane, CH4. You'll have to just know this, methane gas, CH4. This one comes up a lot. Glucose, not as much, but it's in the photosynthesis equation. So you should already know glucose because C2H6O6 gives us glucose. Ethane, we'll talk about a little bit later, and ammonia is NH3, which is also on your periodic table, or not your periodic table, but in your data booklet on the nitrogen cycle page. Ammonia is on there. So that's that. Now, I wanted to talk a little bit about a couple sort of chemical equations. So this is what I was referring to a little bit when I was discussing, it will give you some word equations and you're going to have to form, with those word equations, a chemical compounds, and then you're going to have to balance them properly. So let's, this isn't in your notes. I don't know why there aren't any in your notes, but you're going to have to write this down. What I would like you to do is this. I would like you to first convert copper 2 chloride plus aluminum produces copper and aluminum chloride. Why is that your favorite ionic compound, Ava? I want you to write down the chemical formula for this. So what does copper 2 chloride look like? What does aluminum look like? What does copper look like? And what does aluminum chloride look like? So you're going to have to come up with a chemical equation that we can balance. So I want you to start drawing basically a T-chart with this. And once we've done that, we'll balance it, and then we'll see what it looks like in real life once we've done that. I'm still curious as to why this is your favorite ionic compound. You love the color of copper 2 chloride dihydrate. Well, you're in luck today, Ava. We have some copper 2 chloride sitting right next to me that we'll get to in a second. And it is a pretty cool color, actually. I'm just going to jump over to note so I can write the equation down here. All right, so we have copper 2 chloride. So this is how I recommend we do this. Let's go like this. Copper 2 chloride. So it's telling me copper 2 chloride. That copper, if I can remember the symbol is Cu, I don't even need to look it up because it's telling me it's copper 2. These boxes that are popping up are starting to aggravate me. It's like something on my screen, I think, that's activating the touchpad or something like that. Let's see if I can clean it off. So Cu plus 2. Chlorine is Cl, and it's always -1. So I have Cu plus 2, Cl minus 1. I'm going to form a compound with these two things. So I'm going to crisscross my charges, if you want to think of it that way, or you can think of balancing these things out. Cu, I'm going to put a 1 down here, but I don't need to, so I'm going to lose that. And then Cl is going to get a 2. So that is copper 2 chloride, CuCl2. That's what that looks like. Copper 2 chloride can only form one compound, and that's what it is right there. The next thing it tells me is I react this with aluminum. So normally aluminum on the periodic table has a charge of +3, I believe. When I write down chemical equations, I don't need to include charges. So I'm just going to write this as Al. Then the next thing that comes up in my word equation is produces. And when I see the word produces, I'm going to draw that as an arrow. So copper 2 chloride plus aluminum produces copper, which is Cu, has a charge of +2 or 3. Does it matter which one? Nope, because I'm not including a charge. And the last one is aluminum chloride. So aluminum is Al. Aluminum has a charge of +3. Chlorine is Cl, has a charge of -1. I crisscross my charges, and I end up with AlCl3. So what I'm going to do is I'm going to condense all of this down. And you can see how this sort of type of question involves a lot of work. It's like 4 questions from section 4.2, like name this thing. If I gave you aluminum chloride, what does that look like as a compound? You have to do it 4 times. And if you make a mistake on forming your compounds, when you go to balance it later, you're going to end up with big mess, because if your compounds are incorrect, you can't balance it, or sometimes you can, but it's not going to be right. So what I'm going to do is I'm just going to condense this down a little bit. I'm going to leave a spot for some coefficients. And I'm going to draw my T-chart. We're going to see if we can balance this. So I'm going to write down my elements. I have copper, I have chlorine, I have aluminum. 1 copper, 2 chlorines, 1 aluminum. If I start with copper, chlorine, and aluminum, I must end with them. I'll give you guys a second to balance that. If anyone's feeling brave, they can put their answer into chat. And instead of writing everything in terms of the whole compound, you could just write something like 1, 3, 2, 1, or something like, you can just give me the blanks. So first blank, if it's nothing, you can put in a 1. Let's see what we come up with. Let the speedy people throw their answers in there, and then we can agree or disagree with what everyone got. And then I'll do it. I would recommend just going. Just go for it. Go for copper first. 1 and 1, those are balanced. Chlorine's going to be a problem, 2s and 3s. See if we can come up with a clever solution to the 2 and 3 problem. Anyone feeling brave out there? Anyone have a balanced equation? Abby, thank you for being brave today. 3232. Taylor, you're stuck. What'd you get stuck with, Taylor? Where are you getting hung up? Sometimes with these balancing type equations, you get in these kind of endless loops where you just can't see the light at the end of the tunnel, and you kind of have to just go back to square one and start again and hope for the best. Generally speaking, the questions you get will be, I don't want to say straightforward, they're not going to be super, super difficult ones, but every once in a while they'll throw in a difficult one. Taylor, just start by balancing the compounds first, like the AlCl3 and the CuCl2. The reason you'd want to start with the compounds is because the aluminum on this side is by itself and the copper on this side is by itself. So my reactant side, the aluminum is by itself, and on the product side, the copper is by itself. And the reason it's nice to balance those last is because no matter what you end up with on either side, you can just put a 3 or a 5 or a 2 in there, and it makes it easy. So you can always just start at the top. If you have 1 copper here and 1 here, it's balanced. Then go to your chlorines. You started with 2 and you have 3. So try to balance those out. If you're not able to balance those, then maybe you just need to think, well, if I have a 2 and a 3, what's common to 2 and 3? It's going to be 6. That's the only sort of common ground between a 2 and a 3 is a 6. So I'm going to have to multiply 1 by a 3 and 1 by a 2. And again, this comes with practice. After you've done these a bunch of times, you'll see that patterns develop and you end up with the same types of questions, the same problems over and over and over and over again. So I recommend starting with the easy ones and going from there. And they are fun. Ava, I'm with you. Balancing equations is fun. And they can get tricky. And that's what makes it even more fun. When you can't get it the first try and you have to go back and think of something else and kind of work through it again, that's when it gets good. All right, so what I'm going to do is I'm going to rewrite this equation, and you guys can help me out a little bit. CuCl2 plus Al produces Cu and AlCl3. Now, when we first started talking about these equations, we put in states of matter. And you guys are like, what's with the L, the S, and the G, and the AQ? And you guys were kind of confused as to where these things came from. So what we're going to do is we're actually going to, well, I say we, I'm going to do this experiment right now for you guys. And then we can figure out what sort of states of matter we're dealing with. And this is kind of what chemistry leads to eventually, looking at a chemical equation or saying, hey, if I gave you some aluminum and some copper 2 chloride and you reacted those things together, what gets produced? What happens? And you should be able to reproduce that sort of thing. So I'm going to grab my safety glasses here because, well, safety first. I don't know if these are going to, wow, those look pretty cool in the lights. They're all smudged, but it's the reality. All right, so next to me here, I'm just going to switch over. I'm going to be jumping back and forth here. I have some copper 2 chloride, and I'll get Mr. Ross to bring up the other camera here. So this is what Ava was saying. She loves the color of copper 2 chloride. So that's copper 2 chloride dissolved in some water. So when we talk about copper 2 chloride, I love blue. What type of state of matter is this stuff? So behind CuCl2, what is it? Well, I took powdered copper 2 chloride and I put it away. Sorry, just see if I had there. I took copper 2 chloride in a powdered form. It's like this brown, kind of greeny powder, and I dissolved it in water. So copper 2 chloride isn't a liquid. It's what we call aqueous. Now, you guys didn't get a chance to see me do that, but it is dissolved in water. So this is AQ. So it's aqueous. What about aluminum? What type of state of matter will I have for aluminum? In this sort of room here, why don't we put H2O in the equation? That's a great question. It isn't actually taking part in the reaction. It's just there to essentially create a bunch of surface area for the copper 2 chloride. So normally, looking through these things, copper 2 chloride is a solid, it's a powder. And if I mixed a solid powder copper 2 chloride with some aluminum, nothing would really happen because there's no surface area for those things to react with. Remember we talked about the valence electrons, the outer electrons? That's what's actually forming the compounds, forming the bonds here, breaking those bonds. If I mix them together, I wouldn't have, I just have solids, and solids don't have a lot of contact. If you can imagine, two solids getting placed together. So because it's not part of the equation, we don't include it. It just happens to be there. So I asked what we would have for aluminum, and aluminum would be just like this. So you guys probably have, we call it maybe tin foil or aluminum foil. It used to be made out of tin, but this is, that's a solid, right? So I'm going to put an S next to the aluminum here. That gives me aluminum, which is a solid. So I'm going to mix copper 2 chloride, which is aqueous, dissolved in water, and I'm going to mix it with some aluminum, which is just aluminum foil, which is a solid. Now, you guys already know what's, maybe I shouldn't talk over this. 1 second. All right, so you guys already know what's going to happen, but you're not really sure what it's going to look like. I'm going to end up with copper, Cu, and I'm going to end up with aluminum chloride, or AlCl3. Now, produced in here. And hopefully the Super Miracle Bubbles will trap some of those gas bubbles that I create. So I'm gonna just add this and we'll see what happens. So there's all of the oxygen bubbles being produced. Uh-oh, now I got it on me. Those are all of the oxygen bubbles that were produced, and it's gonna make my skin nice and brown because the iodine in there. You can see my thumb. It's now yellow because of the iodine. So all of that oxygen gas that was produced got trapped in there, and you ended up trapping all of the bubbles. So I'm going to put on a glove now to kind of deal with this mess. I was hoping it would stay standing up, but it didn't. So there's my beautiful graduated cylinder. I trapped all of these oxygen bubbles. One really cool thing that I wanted to kind of do, but I never did, was if I were to take a match or a flint or something that was just glowing but not actually on, and I were to hold it in here in this area, it would actually reignite because this is just pure oxygen in here. And I'm gonna ruin this for Mr. Ross for the sake of science. I'm gonna have to see if I put this on here, that potassium iodide will turn that really dark and black. Let's do it again. Yeah, you gotta do it twice, right? You didn't see it the first time. I was gonna challenge Mr. Ross to see if he could do like a super slow-mo replay in real time, just to kind of keep him on his toes, but I don't think I'll make him do that today. But if we could figure out how to do it, that would be pretty cool. All right, so I'm gonna just get some of this out of the way here. All right, some more miracle bubbles. Super miracle bubbles, sorry. And try to get some of this off my hand. Hydrogen peroxide, again, 30%, so pretty good stuff. Add that in there. Mix up the super miracle bubbles and the hydrogen peroxide. Hopefully it stays standing this time. I don't have to clean up too much of a mess. All right, so hydrogen peroxide in there. We are going to add a little potassium iodide to see if we can't just form some bubbles, and hopefully the super miracle bubbles will trap that. All right, there we go. You can see the steam coming off of it up at the top here. Maybe you can, maybe you can't. That steam is as a result of this foam is actually quite warm. So again, this is an exothermic reaction. We have a lot of heat being released. So if you take that H2O2 molecule and you break it down, you end up producing a ton of heat. And when the reaction first goes off, all the steam rises up because it's so hot. All that liquid water is evaporating as a result of that. You can do it really slowly, or you can do it quickly like I did it. Sometimes if you add really just a few drops of the potassium iodide, it'll slowly grow and then it'll just keep going and going and going, which is kind of cool. Time do we have here? It's about 11. We might as well do one more because I got one more graduated cylinder and it's empty. Let's see if I can avoid making too big of a mess, although I think I've done a pretty good job of that already. All right, so I'll do it a little bit slower this time. This one's empty, so I'm gonna have to add everything. I'll lose the glove here for a second. All right, super miracle bubbles to trap those oxygen gas molecules that are being created. There we go, super miracle bubbles. Now, I don't know if you guys know this or not, but there's something called glycerin that you guys can get at a pharmacy of your favorite drugstore. And if you ever want to make really, really great bubbles, glycerin actually helps bubbles form and stay formed. So have you ever seen people make like absolutely giant bubbles? It's because of glycerin. So that's a good tip. You want to impress your little brother or sister. Get some glycerin. All right, hydrogen peroxide. Just add a little bit of that. Might as well add a lot of that because, well, this is the last go we have. I'm going to mix it up so it's all nice and mixed. And then I'm going to add maybe just a little bit of this potassium iodide because it'll happen a lot slower, hopefully. So here we go. So it didn't add quite as much that time. See how it goes a lot more slowly? See if I can get my... And it's just kind of spewing out. And it'll just keep going and going and going and going and going. And this again is really warm, and I don't know if you can see it. There's definitely a lot of steam coming off the top here. This experiment's called Elephant's Toothpaste, and you can add some food coloring to this, and it comes out in nice, beautiful colors, kind of looks like your toothpaste at home. There you go. So that's potassium iodide. And all the potassium iodide is doing is just helping that hydrogen peroxide break down really quickly. Else we'd have to wait around for it to happen all day. And, well, we don't have all day. My wife's going to say, why is your thumb yellow when I get home? Got that iodine on it. So there you go, guys. That is our couple demonstrations. What would happen if we added all of the potassium iodide? That's a great question. Nothing really. It would just happen a lot faster. So we have a bunch of guests coming in. If they're brave enough to come on camera, they can come stand next to me. And our grade 10s will see you at home,
Hey,
Marilyn.
Hey, Mr. Borden, how are you?
This is Mr. Harbour, counselor at RSS.
Nope, Bushry.
Bushry now?
Good try, though.
Of course.
I'll keep walking.
Yeah. So Mr. Harbour. Anyone else? Anyone else brave?
Hi, Ava.
Oh, you know Ava?
I do.
Oh, there you go.
Mrs. Ferguson.
Mrs. Ferguson. This is Mrs. Green, gonna stick her head in.
Ah.
There you go.
Who are you talking to right now?
Well, all my students over here. So you can see their names. The camera's right in the middle.
Awesome.
Alex used to go to RMS. Do we have RMS counselors here?
I was RMS.
Yeah, Mr. Harbour, I thought.
Okay, let me get out of here.
Yeah, I see that.
Yeah.
Thanks, Alex.
There you go. Alex, do you remember Alex?
I think so, yeah.
Alex.
I have to see a face.
Yeah, we don't have that luxury
I
here.
do see a name, though.
Yeah, so he's nodding. Mr. Harbour's nodding. Yeah, so this is our classroom. We can write on the screen here and doing a couple demos here today. And all the students show up and chat, and Ava says, hello, Nina. Apparently you're not Mrs. Ferguson anymore, you're just Nina. I didn't want to introduce you as Nina.
We are on a first name basis.
Good.
So she's okay there.
There you go. Perfect. And yeah, students are all just kind of hanging out at home, wherever home may be. Taylor's down at the coast. The rest of the guys are in town, or they might be out of town. It doesn't really matter as long as they have an internet connection. And this is my classroom. How's it going?
Do you see your students? Can you see them?
No, just their names. So we have the technology to do that, but
They see you, but you see them.
yeah, just because of some of the clientele, not everyone loves being on camera. Not like me, who has to love being on camera. Yeah. All right, everyone's going back out.
You're not even seeing me. I'm not even here.
All right, there goes Miss Ferguson.
She's here, but I'm not.
There you go. All right, so that was just a small sampling of the counselors in the middle schools and high schools. And I think we're just going to end there. I don't have anything else to mention in terms of balancing or compounds or anything like that. If you guys want to come today at 1 o'clock, I'll be here, answer any questions you have about anything science related. I know Abby's coming for sure, and maybe a couple others. And if I don't see you this afternoon, I'll see you tomorrow morning at 9 o'clock at Hollywood Road. And when you guys first walk in the doors at Hollywood Road, there's kind of like a main entrance. I believe we're the first room on the right. Myself or Mrs. Wood or Ward will all be standing out there, so we'll be able to herd you in there. But yeah, that's kind of where we're at. So we'll leave this. This is the end of 4.3. I won't talk about chapter 4 again. If you guys get the learning guide in by middle of next week, that'd be great. Obviously, we have the test tomorrow. You guys want to focus on that first. There'll be no Unit 4 test. And we'll just leave it at that. So thanks a lot, guys. I look forward to seeing you tomorrow. Taylor will send you an email and let you know what to do with that test. And there we go. Thanks, guys. Have a great afternoon. Ever seen copper before? What does copper look like? Is there anything in your everyday life that you encounter all the time which is copper? And can you describe what it looks like? I wouldn't expect anyone to have encountered aluminum chloride before, but it is brownish copper wires. Brilliant. So you know what? There's like my son, he's going to grow up his entire life. He won't know what a penny is. So copper wires in houses are made of copper, and they're kind of that brownie color. Pennies are kind of coated in copper. So I'm starting with a blue liquid and this kind of shiny aluminum, and I'm going to end up with copper. So we're going to have to look for some copper to be produced here, and we're going to see that as kind of a brown thing. Is the copper going to be a metal? Is it going to be a solid, a liquid, a gas? What are we thinking? That's one way, Abby, to get a pure element. But generally speaking, we're going to kind of mine it out of the earth. And a lot of times we'll use the fact that things melt at different temperatures. So if aluminum maybe turns to a liquid at a lower temperature than, say, copper, I could separate the two by heating it up past the liquid temperature of 1, and then the other one will remain solid. And liquids and solids are easy to separate. We got going to be solid, solid, solid. All right, so a bunch of you have probably seen this before. I'm going to step over here. I'm going to add our aluminum into our copper 2 chloride here, and we're going to see what happens. So it kind of just sinks there, and we'll give it a second to react. Not much going on. See if I can get my mic close to it and you can hear. Can you hear what's going on? There's some gas being produced. Got some bubbles happening. You can see it's slowly starting to darken the liquid down at the bottom here. So it's no longer that really nice, beautiful blue color. You maybe see some bubbles being produced on the front here. And we end up with some brown happening. Now, I don't want to get my fingers in there, but what I'm going to do is just going to pull a piece of this out. And you can see on the bottom, it's no longer that real shiny aluminum color. It's kind of a dull sort of browny color. And that is right on the surface there. The aluminum is turning into copper. Well, I shouldn't say it's turning into copper, but the aluminum foil is going to slowly disappear. And we're going to end up with just give it a little stir. You see that? It's this really brown color now happening. One other thing that's also happening that you guys won't be able to experience because you're there, but this beaker is quite hot, and it's what we call an exothermic reaction, which means that each one of those bonds that we have formed with the copper 2 chloride, each one of those bonds breaks, a little bit of energy gets released, and that energy gets released as heat, and there is some steam coming off this. So it's getting hot enough to kind of boil some of that water. You can see some condensation forming on the inside of the glass here. Now, copper 2 chloride's not something you have in your kind of everyday life. It is some pretty nasty stuff. Today I took off normally I wear my ring and my watch. I took it off because if I were to get some copper 2 chloride on my ring, it would take that titanium that's in my ring and it would replace it with some copper. So literally I would dissolve my ring or my watch, the same sort of thing would happen. So you can see that we're ending up with this kind of really brown stuff happening here. It's still bubbling away. And that nice, beautiful blue color is kind of gone. So I'm going to let that just continue to react for a second. And I'm going to jump back over to my computer here. And we can maybe talk a little bit about what we have happening here. So, lose these for a second. We have our copper 2 chloride, which we started with, which was that nice blue color that Ava really loved. And that was aqueous. It was dissolved in water. And then we had some aluminum foil, which was just a solid, just like this stuff right here. Same as what's in your house. Stole that from my kitchen before I came to work today. And then we produced some copper, which is that nice brown stuff. And then everything that's left is aluminum chloride, so AlCl3. So the beaker is taking all of that stuff and basically what's left over. There's going to be a little bit of copper 2 chloride left in there if it all doesn't get reacted. And we're going to produce some aluminum chloride, which is basically, you can't really see it, it's dissolved in the water. And there you go. So that's one type of reaction that I wanted to look at. Looks like we have a few more minutes left here before we take a break. And I wanted to do one more demonstration for you guys. So we'll look at one more equation. And then we'll go from there. Jump back over to my slides here. All right, so copper 2 chloride plus aluminum produces copper and aluminum chloride. You would be expected to be given an equation like this, and you would be expected to be able to produce the word equations, so like the chemical equations that I did, and then balance it from there. Did I not indicate those? Oh yeah, Abby, thanks for reminding me. The last two states. I didn't want to, be presumptuous and just write them in because we never really decided, but if I look next to me, and maybe we can switch over to the beaker again, there's a bunch of brown stuff in there, and it's kind of hard to see from this angle, but if I pull this aluminum foil out, you can see that on the surface of this aluminum, there's this really brown solid that's formed, and here's a big chunk of it. So that brown solid is copper. So it's metallic copper. It's formed in like a really fine powder because it's formed basically one atom at a time. Give that a stir so it finishes reacting. But that copper that was produced was a solid. And you could observe that just from what was going on in there. The aluminum chloride's a little bit trickier. We don't really know what it looks like, so we're not really sure what we're looking for. Copper, we had, everyday occurrences of that, but the aluminum chloride, not really sure what that's going to look like. It ends up just being dissolved in the liquid water there. So because it's not solid and aluminum chloride is probably not likely to be a gas, I would have to assume that this is aqueous. So it just continues to be dissolved in the water there. So those are the last two states that we end up with. We end up with copper, which is a solid, and then aluminum chloride, which is aqueous. So I could put all these together in a balanced equation, or even up above here, I could put in the aqueous here and the solid, and then we had a solid, and we have aqueous. And that sort of thing will happen from time to time where you'll see those things in there. If they're not there, don't get worried. It's not like they're a big deal, but when they're in there, don't get worried either. There's nothing sort of special about them. So they do just kind of occur that way. Now, I'm trying to think, it may be good if we took a bit of a break here, because we have our guest showing up here shortly, and maybe that would be the best idea, to take a little break, and they won't disrupt us, or they may, we don't know. But I want you guys, if you haven't, in the learning guide, if you haven't gone through all of these balancing questions yet, you should have basically like 2 or 3 more to do. I'd love it if you guys could do that. I will also upload a few more challenging questions in terms of balancing, and if you guys want to do those, I would strongly encourage it. Just kind of make sure that you are really good with this balancing stuff. So I'll upload some more difficult questions. Yeah, Alex, I'm not sure what's up with your learning guide. It looks like some of the pages on mine aren't numbered. So we have 33 right there, and this is 34 and 35. For whatever reason, you got an extra page. And I don't know if it's as a result of maybe just things being spaced out differently or what it is, but I'm going to assume that it's just a formatting type thing. So just go with it, and we'll do the best we can with what we're given, and I will keep this in mind when I go through it. I doubt you're missing anything. I'm thinking it's just formatted differently, different sizes, your printer printed off in different format or something, and you end up with that. So we'll maybe take a 10-minute break. We'll have these questions, these balancing questions. I want you guys to finish those in the 10 minutes and grab a snack, get up, walk around, get some blood moving. When we come back, I'll show you a few more challenging questions, and then we'll do the last demo, and we'll balance that, and we'll do the word equation. And then we'll probably finish a bit earlier today, so you guys can have some time to study or whatnot. So there you go. So we'll see you guys in 10 minutes, and make sure you do all of the balancing questions from the learning guide, so you can ask questions about them if anything comes up. Thanks. Hi guys, welcome back. Hopefully you guys had a chance to go through some of those questions. What I did while we were waiting was find the course here. I went into the course and I uploaded some additional balancing type questions. So if you guys are, think your balancing is really good, I put some challenge ones in there, and I wanted to go through at least a couple of them for you guys to wrap your heads around. So right here, I call it Balancing Extra Challenge. So I know you guys haven't printed this off or anything because I just uploaded it right now, but it will be some great extra practice for you guys to go through. And what I'm going to do is I'm going to just fire this onto my desktop, and I'm going to upload it into OneNote here. Maybe. And I'll do a couple of them. If you have some time to print them off, it'd be great. Somebody earlier asked, hey, Mr. Bourne, when's this learning guide due? And we'll make it due next week on Tuesday or Wednesday. And that will give you guys lots of time to get it done. And of course, I want you guys to focus on the midterm tomorrow. Oh no, it printed out in mini size. That's not going to be very good. So what I'll jump back over here. So if you guys open it up, you can see that there's question 8, 9, 10, and 11. And I drew a little line here next to questions 10 and 11. The learning guide that you guys have, the notes goes up to question 10, and then we are on question 11. So 11 is the additional material. So there's 11, 12, 13, 14, 15, 16, 17, and 18, 19, 20. I think you guys did 19 and 20. We did 19 and 20 in the learning guide. Those were the two challenging ones. So these ones aren't impossible. It's not like these are the most difficult questions you could possibly do. They're just some balancing ones, and they are just questions you should definitely go through. They're a little more challenging than the ones that are in the learning guide, with the exception of the last two from the learning guide. Those last two are really hard. These ones are definitely not impossible. They are in there though, and you definitely should have a look at them. It'll be very worth your while. So, did anybody have any questions about that? You just printed it off. I guess some of you guys have printers just hanging out around your house. I guess I have one too. I just kind of take for granted that it's there because I have one at work, and I don't really print a lot off at home. So one thing I didn't do when we came back was green check marks. So if you guys want to fire those in, I know some of you have written, but I just want to make sure everybody's kind of picking this up because the internet has been so intermittent lately. Might do them next week for sure, and there's really nothing wrong with that. It's just important that they eventually get done, because if they're not getting done, then you guys might struggle with this stuff a bit. And actually the next unit, Unit 6 that we get to, is more balancing, and it's types of reactions, and it's more of the same stuff. You'll kind of see why it's its own unit, but it's more stuff related to the same types of things. Perfect. Thank you for those of you who put in green check marks. It's always nice to know that I'm not standing here talking to myself, because that happens more than you'd think. I'm going to do maybe one of these, and then we'll get to the last example here, and I wonder if I can take just a little snip of this and then load it into OneNote, because it gave me mini size. There we go. That worked out. When do we move on to motion science? This is a good question. We have 2 more units of chemistry, and then we end up with motion. The physics section is the last stuff we do. So we won't actually get there until probably June. The most of May will be continuing on with chemistry. And we have 1 chapter on radiation, radioactivity, which is kind of technically physics, but it kind of looks like chemistry. And then we get onto the motion as the last sort of unit. So I guess while we're talking about it, the first midterm chemistry is no fun. Come on, it's great fun. The first midterm that we're going to do today, or tomorrow, at Hollywood Road, that midterm is on chapters 1, 2, 3, 10, and then a little bit of 4. We won't have a test on this balancing stuff because it comes up again in 6, so we'll kind of tie it into the chapter 6 test. And then I'm not sure if we're going to do a midterm at the end of the year or not. We might just do a final exam online that has a little bit more of the second stuff that we've done. So that's kind of, I guess, where we're at, where we're going. I was talking to a teacher that I know at KSS, and he's at the exact same spot as us right now. And what we're going to do in a couple weeks is hopefully we're going to go in, at least I am going to go into KSS, and we're actually going to film at KSS instead of filming in our studio here. And we're going to see how that works out, do some fun experiments and things that we can't do in the studio, things that we can only do in a science lab. So there you go. All right, so this is a good question to do. It's a tricky one. Maybe you guys can do it along with me. So we have AL, we have C, we have H, and we have O. If we start with AL, C, H, and O, we have to end with AL, C, H, and O. The reason I do this example is because in the second half, or my product side, you can see that I have this OH group. And when I'm counting my atoms, I don't ever, because it's not OH on the reactant side, there's no OH here, it's actually H2O, which is a different compound than the hydroxide. I don't want to balance it as a group, an OH group, because it doesn't exist on both sides. If I have an OH here and I had an OH here, I could balance it as a group, but because I don't have it as a group on both sides, I can't. I have to balance everything separately. So what I'm going to do is just look at this like I've looked at everything else. So Al, aluminums, I have 4 of them. Carbons, I have 3 of them. H, I have 2. And oxygen, I have 1. And over here, this is why counting's so important. I have 1 Al, I have 1 C, I have 4 H's, plus another, so there's 4 H's here, and there's another 3 here. So I have 7 H's. And my O's, I have 3. Alex, we don't ever get to play with liquid nitrogen because it's not really a toy to play with. I mean, it's kind of dangerous stuff. You can do some serious damage with it. So unfortunately, no. What I would love it if you guys would attempt this question right now. Now, Taylor, you're like, where do I start, Mr. Borden? And that's a good thing to ask. The aluminums would be a great place to start. I have 4 here, and I have 1 here. So if I have 4 on my reactant side, I need 4 on my product side. So what I need to do is throw a 4 out here and see what happens. So that changes my aluminums to 4. So this goes to 4. My hydrogens and oxygens also change at the end here. So I have 4 groups of 3, which is 12. So my oxygens, I've gone from 3 to 12. And my hydrogens, I have 12 here, and then I have another 4 here. So I have 16. So I'll leave that with you guys for a second to see if you can trudge away at the rest of it. It is a tricky one. Do your best, and I'll give you guys a second. So if anyone is feeling brave and they want to put in their answer, I think this one, although the numbers get a little bit big in terms of counting, I think it works out kind of okay. There's no sort of erasing or going back. once you start kind of rolling down the path of balancing it, it might kind of work out. And if you get to the end and it's not balancing, you're kind of going around in circles, yeah, for sure, take your time going through it. If you're kind of going around in circles, maybe you started with the aluminum, then you went to the carbon, then you went to the hydrogen, then you went to the oxygen, it didn't work out for you. Erase it all, start again, and then try to do the elements in a different order. Go aluminum, then maybe hydrogen next, and oxygen. It gets tricky when you get things in more than one spot, and you end up kind of going around in circles. So keep going, see if you can get it. It is a trickier one. Look at you guys, all getting the same answers. Nothing 12, 3, 4, as in what I filled in. Yep. Ava, Abby, anyone else? I haven't done it yet, so I'm not sure what it's going to look like, but you two girls are, it did kind of work out in the end. And it's funny how they do sometimes just work out for you. Let's keep going. So as I was mentioning to everyone, pick somewhere to start. If you want to start with aluminum, that's good. You get them balanced, 4 and 4. The next thing I'm looking at is my carbons. You can see here that I have 3 carbons on the reactant side, and I only have 1 over here. So I need to end up with 3 on my product side. So what I want to do is add a 3 in front, the coefficient. That changes my carbons from 1 to 3. And once I'm there, that also changes my hydrogen. So I have 3 groups of 4, which is 12. And then I have 4 groups of 3 here, which is another 12. So my hydrogens go from 16 to 12 and 12, which is 24. Again, getting back to the idea why counting is so important. Counting these things. All right, so my aluminums are balanced 4, 4. My carbons are balanced at 3 and 3. My hydrogens are not balanced. I have 24 on the product side, and I only have 2 on my reactant side. So what I need to do is get 24 over here. I need to end up with 24 hydrogens on my reactant side. In order to do that, I need to put something in front of this, which is then going to get multiplied by 2 to end up with the 24. So if I were to put something in there, I would put a 12 in, because 12 times 2 gives me that 24 that I needed. So I'm going to cross this guy out here. Instead of having 2, now I have 24. And my oxygens went from 1 on this side, and the 12 in front gives me 12 of them. So with something like this, it's worthwhile to kind of go back and double check, make sure everything looks good. So aluminum's 4. I have 4 here. I have 4 here. So I'm happy with that. 4 and 4, those worked. Carbons. On my reactant side, I have 3. And then on my product side, I have 3. So that one worked. Hydrogens, 12 times 2 is 24. So I have 24 there. And then this is where hydrogens get tricky, because you have 3 groups of 4 here, and you have 4 groups of 3 here. So this is 12, and this is another 12, and together you have 24. And the last one, oxygens. 12 oxygens here, and 4 groups of 3, 12 oxygens there. Whew, look at that. Amazing. We did it. Let's do one more, and then we'll get to our last demo, and then we'll call her a day. Last demo shouldn't take too long. Which one? Let's pick a good one here. 15, I don't like that one. 16, ooh, that's a tricky one. I don't want to make it too hard, but I don't want to make it too easy. Let's do 16. It looks really messy, but it actually kind of works out quite nicely. All right, so get the right keystrokes there. Brilliant. All right, so there are some compounds here. And when I did a couple examples, on the learning guide, page 19, mine is blank. Did we go through those ones? I think I skipped 2 questions from the learning guide, so I'll let you guys go through them on your own, and then the answers are at the back, so you can just see if you got to the right spot. When I did the few examples out of the notes, I balanced polyatomics as groups on either side because they were the same on both sides. Now, this is going to be really tempting to balance these individually kind of as a group because I see I have K2CrO4. But on my product side, it's not K2CrO4, it turns into K2Cr2O7. So we're actually bonding, or a new sort of polyatomic is being formed here as part of this reaction. So because they're not on both sides, we're going to balance all of the elements individually. So I have K, I have Cr, I have O, I have H, and I have Cl. That's a lot. Don't get intimidated. The process is exactly the same. Again, if I start with potassium, chromium, oxygen, hydrogen, and chlorine, I must end with them. If I start with it, I end with it. Law of conservation of mass. 2 potassiums here, 2 potassiums here. I have 1 chromium, 2 on the product side. My oxygens, I have 4. I check for oxygens in both spots just to make sure I don't have them in more than one location, because that happens over here. Now I have 7 oxygens plus another 1 is 8. Keep going. Hydrogen, I have 1, and hydrogen over here, I have 2. And then chlorine, I have 1 over here, and chlorine, I have 1 over here. All right, I'm going to leave that. I got you guys started there. I'm going to give you guys a couple minutes to see if you can you go through this and balance it. And don't be intimidated by there being so many of these elements. It's the same process. Be confident in what you're doing. Be confident in the method that you choose is going to work. And I'll tell you right now, the numbers don't get big. It kind of just works out like the last one, but you just got to kind of go through and figure out where it needs to work out. So if I were to begin this as a place to start, I see I have 2 potassiums and 2 potassiums. And that's balanced, so I don't have to worry about that. The first spot I run into a problem is the chromium here. I have 1 on my reactant side, and I have 2 on my product side. So I would recommend starting with a 2 on your reactant side. Is there 3 potassiums on the right? Oh, yes. Maybe that's why. Thank you very much, Abby. I even mentioned it to not make the mistake, and then I just kind of overlooked it. So start at potassium. That's a great place to start. Thank you, Abby. 2 and a 3. So start with that and see where you end up. And the cool thing about the potassium on the right is that you end up with it in 2 spots. And I'm going to recommend thinking about making this even by putting a 2 here to get going. Because that gives you 2 potassiums and another 2 changes that to 4. And then your CLs go from 1 to 2. Start with that. See if you can go from there. And apologize for not finding that other potassium. All right, it's great to see you guys throwing in answers. And you know what else I really love is that it's not, I mean, Ava and Abby are really into this stuff and really doing well. But Anna, thank you for putting an answer, and same with you, Taylor. It's good to see some people who aren't normally always putting in answers. It shows me you guys have a bit of confidence in this stuff, which is good, because that means you know what you're doing when you're confident enough to put it out there. And if you get it wrong, it's not the end of the world. Like, I'm not going to ridicule you or anything. So just be brave every once in a while. Try to step out of your comfort zone if you can. And if not, that's okay too. As long as you're getting this stuff, it's all that matters. So I miscounted. We have the 2 and the 1 spot over here. And then we can continue. Because I added the 2 there, that unbalanced this guy. So I'm going to put a 2 here now. So it gives me 2 potassiums on the left. My reactant side now changes to 4. My chromium changes to 2, and my oxygen changes to 8. So we're doing okay. 4, 4, 2, 2, 8, 8. We're looking good here, actually. 4, 4, 2, 2, 8, 8. And then hydrogens aren't balanced. So I'm going to go ahead and put a 2 over here. That gives me 2 hydrogens, which changes that to 2. It also changes my chlorines to 2, which just kind of worked out. So you'd be surprised how many times you go through these types of questions and everything just kind of works out. And it seems like really unlikely that it will, but it will. It has to. If you've done everything correctly, if there's no typos, that's always the worst. Absolute worst as a teacher when a student comes up to you and says, hey, Mr. Borden, I've been trying to balance this for a while and I'm running into problems. And you look at it and you're like, well, you made a mistake on this compound here. It's like CuCl3 instead of CuCl2. And then, they look at you and they're like, oh no. So you gotta go back to square one and start again and change your compound. So sometimes it happens, but when possible, try to just go back and double check your work. And you're right, completely right, Anna, that it did look scary. There's tons of letters. There's, we're balancing potassium, chromium, oxygen, hydrogen, chlorine. There's lots of things to balance there. And, it just kind of worked out that it just works. Like, these things have to work out. There's some that are really big and unruly, but you don't run into them too often. All right, I want to jump back here, get to our last demo, and then we'll finish off for the day. So we did copper 2 chloride plus aluminum produces copper and aluminum chloride. And the next example I want to look at is this. Hydrogen peroxide breaks down to produce water and oxygen gas. Now, they've given us, some word equations. We need to form a chemical equation with them, or form our compounds. And then once we've done that, then we can balance from there. So maybe let's do the balancing first. I'll do the demo next, and then we can be confident in what we've done. So is anyone familiar with hydrogen peroxide? I have a bottle of it here, actually. There we go. Has anybody ever used hydrogen peroxide before? Maybe I'll throw it up here, get Mr. Ross to switch cameras. There's hydrogen peroxide. You can buy it at any sort of pharmacy. This is Safeway brand. You've used it before. A lot of people use it to disinfect like cuts or things like that. Yeah, probably have it in your medicine cabinet. Yeah, exactly. So you guys are somewhat familiar with it. Hydrogen peroxide sounds pretty cool, and it has a really interesting chemical compound or chemical formula. And the actual formula that we're going to write here works out to be a little bit different. So I'm going to just make myself some more room here. Hydrogen peroxide is H2O2. Rubbing alcohol is not similar. Rubbing alcohol is rubbing alcohol, and alcohol is different than hydrogen peroxide, but hydrogen peroxide is H2O2, and people used to use it a lot to disinfect cuts. And when we look at the chemical equation here in a second, we can figure out why that was. So hydrogen peroxide reacts to produce oxygen and water. So I have H2O2, oxygen. Now I know water is H2O. It's just kind of one of these common things that we always encounter. And we don't use dihydrogen monoxide, its chemical name. We just use the H2O. It's dihydrogen monoxide, but we just call it water. It has a common name. Everyone uses the common name. Now, the reason I've left oxygen for now is because oxygen is one of the magic 7. Now, you're going to be tempted to write oxygen as an O and just leave it. And if you did that, nothing would work out. It wouldn't balance. You'd run into all sorts of problems. But when we have oxygen by itself, it is one of the diatomics, or the magic 7. So maybe I'll just jump back to my slides here. Oxygen's obviously up here above my head. I guess it's not obvious, but you've encountered it probably a few times to know where it is. It is one of the magic 7. So when oxygen exists by itself, it never exists as just O. It always exists at O as O2. The tricky bit here is that when you guys are doing problems, it will say hydrogen peroxide reacts to produce oxygen and water. It will not tell you that oxygen is diatomic. It will not remind you. Never. It is something you need to know. If you're dealing with oxygen, hydrogen, chlorine, fluorine, bromine, these things all exist diatomically. Kind of almost sounds like diabolically. They're diabolical. Those 7 famous artists. Who are the 7 famous artists? You thinking like the Ninja Turtles? My son has Ninja Turtle toothpaste at home, and he's really young, so I don't let him watch Ninja Turtles because it's kind of violent for a 3-year-old. But they all have like, he always asks, what's this guy's name? I'm like, oh, that's Leonardo. When I was like a little kid, Ninja Turtles were fun, and now they're fun again. Interesting how these things come and go. All right, I'm going to rewrite this. H2O2 reacts to produce O2 and H2O. H2O2, 7 Canadian artists. Audio's not working. Can you guys hear me? Is it just Mr. Ross that's having issues hearing me? Can you guys just type into chat if everything's peachy? Thanks, Alex. Just Mr. Ross having issues. I don't know. You can hear. Everyone's good still. Mr. Ross, it might just be your things. Perfect. Thanks, guys. The 7 Canadian artists. Savannah, you probably are into them? 7 Canadian artists. The 7 Canadian artists. Perfect. I'll just keep going then. Excellent. Well, thanks. I'm not familiar with 7 Canadian artists. I'm not much of an artist kind of guy, so I would assume that I know Savannah really likes art, and maybe even Ava, because you brought it up. If you guys do have issues with the audio, I know you'll just type into chat, and that'll be fine. So H2O2, it comes in a brown bottle. It is a liquid, and then oxygen is going to be a gas that's produced, and then H2O is just going to be liquid like water. So can you guys, are you happy with that? Did I make any mistakes there? Are we're all in consensus that looks okay. Again, if the states of matter don't show up, definitely not the end of the world. But we know them. Water is going to exist as a liquid at room temperature, so I'm a little cold in here, but it's room temperature. Oxygen is a gas at room temperature. You'd have to make it really, really cold to turn it into a liquid. And then H2O2, hydrogen peroxide, is going to give us a liquid in the kind of brown bottle that you go buy at the grocery store. All right, so let's balance this. We have H, we have O. Isn't it kind of interesting how this is a chemical equation and there's only one reactant? So there's only two things happening here. Kind of weird, not like we've encountered before. So we start with 2 hydrogens, 2 oxygens. We end with 2 hydrogens and 3 oxygens. And this is one of these examples where you end up wanting to get an even number because there's nothing over here I can do to make this odd. I can't put anything in front of this 2 to make my oxygens odd. So what I want to do is make it even. Should make life a lot easier. So I'm going to put a 2 here. Gives me 4 hydrogens and 4 oxygens. And then I can put a 2 here. So, oh, I don't need that. What have I done? I'm not thinking straight. Let's jump over here. Not that. Let's jump right here. There we go. So 2 H2O and 2 H2O2. So what's happening is we're going to have 2 of these atoms of hydrogen peroxide. They're going to break down into 2 waters and then 1 molecule of oxygen. So 2 H2O2 gives us 2 H2O and 1 oxygen. So for a second, maybe think why people would put this on a cut. You put this hydrogen peroxide on a cut. Why would people put this on a cut? What's happening? And Alex, yeah, you're right. We could turn anything into a solid if we got it cold enough. Well, not anything. There's a couple of things that get solid at very, very cold temperatures. But yes, it is conceivable. Hydrogen peroxide stuff you put on cuts to not get infected. That's exactly right. Now that we know what this equation looks like or the reaction looks like, if I were to put it on a cut, what would happen? Well, I'm going to put this hydrogen peroxide, this H2O2 down there on the cut, and it's going to basically, it kind of looks like H2O. It's just a clear liquid. It's really similar to oxygen, or not oxygen, it's really similar to water, but you put it on and it will kill bacteria. It actually dissolves the cell walls of bacteria. So that's a great thing. What's produced once it breaks down on your arm? It'll slowly break down into water and oxygen. Those 2 things are really good for us, aren't they? Oxygen, perfect. We breathe it in every day. It's important stuff to keep us alive. And water. So the bubbles that you see, Alex, if you've used it on a cup before, the bubbles are as a result of the hydrogen peroxide breaking down into water and oxygen. And the bubbles is just oxygen gas that's being created. What's left over is just the water. So you end up with some water and some oxygen gas being produced. So 2 things that you can live with. All right, so when you go to the drugstore and you get this hydrogen peroxide, it's 3% hydrogen peroxide. What that means is when you pour this clear liquid out, 3% of it is hydrogen peroxide. The other 97% is just liquid water. So they just dilute it. Now, I never satisfied with 3%. So what I do is I always go to a store and I get 30% hydrogen peroxide, which is a lot better than 3%. What I've also done is this. I'm going to switch over to my other backdrop here. So I've got a graduated cylinder here, and everyone's favorite, Super Miracle Bubbles. Now, we just discussed that we end up producing all of this oxygen gas. And because we're producing oxygen gas, I can trap that gas if I put some bubbles. So down in the bottom here, you can see there's a bit of liquid down there. That is Super Miracle Bubbles. That's what's going on down there. Now, this here is some hydrogen peroxide, 30%. And I really should have gloves on, but I'm going to be very careful not to get it on my skin. Basically, it turns your skin white. It just kind of kills the cells on your skin, just like it would kill bacteria. And I'm going to add this hydrogen peroxide to the graduated cylinder. It's probably a lot. There we go. And I'm just going to mix it up a little bit. So I have miracle bubbles in here, and I have some hydrogen peroxide. Just two clear liquids. Now, if I left this, it would eventually just decompose like the equation we wrote down. Oxygen would be created, so the oxygen just kind of would evaporate off, and then I'd be left with water. So it happens really slowly over long periods of time. If I were to add something like you guys were mentioning that you use it on cuts, the cuts that you're treating, the oxygen gas gets produced because of a reaction that occurs with your skin cells and the hydrogen peroxide. So if you were to add this, you end up with these bubbles being produced. Now what I have here is some potassium iodide. I've just dissolved some solid potassium iodide in some water. And potassium iodide kind of works like your skin cells. What it's going to do is it's going to help the bubbles or the gas